So our next section is the half-wave rectifier with reservoir filter. So in last video we have seen the two blocks, that is the first one was our transformer given to a rectifier. So under rectifier you had half wave, full wave and bridge, and now the next section will be your that is your rectifier with filter or reservoir filter. Okay, so let us take the diagram for the half wave rectifier. Let me draw it once again. Okay, so half wave rectifier, the input was from your mains, which is to 40 volt. You have a step down transformer which converts it into 12 volt, right? Now you had half wave rectifier, a single diode. So this was your diagram of your half wave rectifier, right? Now this will be your ground. So let me take this as diode D1. Now why do we go for a reservoir filter? Reservoir filter, as I have mentioned before, it is nothing but the addition of a capacitor in order to reduce the ripples or in order to reduce the AC components. So if I add a capacitor in addition to this circuit, then this capacitor C1, the combination of this capacitor C1 is called as your filter. It does the filtering process. Okay. This capacitor C1 is also called as reservoir capacitor. Now, what happens to the circuit? So, yesterday we have seen, in the last video we have seen the waveforms, right? So, let me draw it once again. So, how was your waveform? So, the waveform from the secondary winding, okay? Secondary winding was a sinusoidal signal, right? Let me take it as V in. That is the input to your rectifier, right? So this was your sinusoidal signal, which was having a peak of, what was the peak? 17 volt minus 17 volt, right? Now, what was your next wave? The second wave was your, so once it is done, so here in the case of filter, I am taking two waves. The first wave will be the output waveform at RL without capacitor. So without capacitor, which was same as that of your previous half wave rectified output. So what happens? During the positive half cycle, you will be getting the signal. During the negative half cycle, you will not get the signal, because we have seen the explanation in last video. Okay, so this is your output without the presence of the capacitor. Now same waveform. Now we are going to find out how we are getting the waveform, how the waveform is transformed when we apply the capacitor. So V0 at RL with C, with the capacitor C. So let me take this capacitor as C1, right? So C1. Okay. Now we will draw the, we will explain, with the explanation we will see how our output looks like. Okay, so what happens during the positive half cycle? So during the positive half cycle, here it will be positive, here it will be negative, again positive, negative. So positive and positive, the diode D1 will be forward biased. Okay, the diode will act as a closed switch. Okay, so there will be a current flow, right? Now what happens? The same voltage what you get across D1, you will be getting the same voltage across C1 and RL. So RL and C1 will be having the same voltage. Why? What's the reason? Because it is parallel connection, right? It acts as a potential divider here. So whatever the signal is in C1, you will be getting the same signal at RL. So during the forward bias, I am repeating it once again. During the forward bias condition, the same voltage reaches this junction C1. So once it reaches this junction, what happens? The capacitor starts to charge. Okay, so what will happen here? Let me take another color. So the capacitor starts to charge. Okay, till where? Till it reaches the peak value. So what was your value here? Peak value was 16.3. Okay, after the drop. So the capacitor starts charging and it charges till the peak value. Once it reaches the peak value, what happens? The the capacitor starts to discharge slowly. So let me take, so till it reaches the peak value, it starts to charge. If I take this as time period t1, 0 to t1, the capacitor charges very rapidly. Okay, the capacitor starts to charge very rapidly. Okay, means very fastly. Once it reaches this time period t1, what happens to your input voltage? The input voltage is starting to decrease. So at that time, what will happen to your diode? The diode will go back to your reverse bias, will act as a reverse bias condition, and it will act as an open switch. Okay, so it will now the capacitor has charged till the peak value. The capacitor, this is your output, it has charged till the peak value, and now the capacitor stores that particular voltage, right? Now what will your circuit look like? So after T1, I am drawing, your circuit will look like, so this is your 12 volt secondary output, 12 volt, then your diode will act as an open switch after that condition, right? So you have a capacitor C1 and you have an RL. Now what will happen to the circuit? The circuit looks like this. There is no connection. There is no current flowing. Now the capacitor has reached the maximum value. Slowly the capacitor starts to discharge. So what will be your discharge path? Your discharge path will be across your RL, right? Okay. So why your discharge is very, very less? Here your discharging rate is very, very less. Is very, very less. What is the reason? Because the value for RL is very, very greater. Okay, so since the value of your load resistance is very, very greater, the capacitor discharges very slowly. So see here, the capacitor starts to discharge very slowly. During the negative half cycle, it starts discharging. Once it reaches this point, what will happen? Your input again rises. So again the capacitor starts to charge. The process repeats itself. Okay. So this is your, since this capacitor holds or stores the voltage, it is called as a reservoir capacitor. Okay. It is very simple. The diagram is, you have to add, in addition to the half wave rectifier, you are going to add a capacitor. So here there will be small ripples present. So these are the small ripples which is present. These ripples can again be eliminated if you choose a capacitor to be a very greater value. So if you use larger value for the capacitor, you can reduce the ripples further. So it is maintaining in a constant value with few ripples. So if I draw the same reservoir filter in the case of full wave rectifier, what your circuit looks like. So full wave rectifier. So in the case of full wave rectifier with filter or with capacitor filter, so how will your circuit look like? So you have your center tapped transformer, which is 240 volt in the input, right? So here you have, if I take this as A, B, C, okay, you have two diodes here, diode D1, diode D2. It is center tapped, so you will be getting the value across RL. Now what is the additional feature what you are going to add? You are going to add a capacitor C1, which is nothing but your smoothing or your reservoir filter. So the diagram will be, how will your diagram look like? The diagram will be same as that of the previous class, only with the addition of C. What will be your, so let me take this as your input. Okay, input V in from the secondary winding. So what will be your output? Let me take similar to that of your half wave rectifier. Okay, so we'll take two cases without C1 and with C1. So let me take this as V out without C1. So you will be getting full wave. Okay, full wave rectification. Now what will be your V0 with C1? Same concept. So if I put it in a dot wave, what will be your output now? I'll give the output in a different color. So the capacitor starts to charge till the peak value, then it slowly discharges once it reaches the higher input value. Now what will happen? Sorry, the capacitor starts to charge again, discharging. So this process happens. So in both the half cycle you will be getting the signal, okay, due to the presence of two diodes. I can take now I'll take another paper. Now I'll draw the diagram for bridge wave rectifier. Bridge wave rectifier with filter or with capacitor filter. Okay, now the diagram will be again same. The only addition is you are going to add what? Your capacitor. So this is your 240 volt, right? The transistor T1. Here your center tap is being avoided, so you will be taking 4 diodes. Diode D1, D2, D3, D4, right? Positive, negative. So D1, D2, D3, D4. Okay. So here is your output. So normally you have, this is your bridge rectifier, V0. Now you are going to add a capacitor C1. The diagram will be same as that of full wave rectifier. Next section is your last section, that is your voltage regulator. Okay, so these are the 3 different diagrams of your filter along with the rectifier.